In this video, we'll be talking about square root and cube root parent functions and how to transform them, and domain and range and all that fun stuff. So your square root parent function is f of x equals the square root of x. So that's going to look like half a parabola on its side. So you're going to start here at 0, 0. Then you're going to go over 1. And let's just do this. X, y, 0, 0, 1. The square root of 1 is 1. So I'm only going to pick perfect squares. 4 is 2 because the square root of 4 is 2. And then let's do 9, which will be 3. If we connect our points here, that would be my parent function. My endpoint would be 0, 0. My domain would be x is greater than or equal to 0. And my y would be my range would be y is greater than or equal to 0. So that's the square root parent function. And then my cubed root parent function is f of x equals the cubed root of x. And let's just go ahead and make our little table. This one I can have negatives. So let's put 0 in the middle. Let's do -8, -1, 1 and 8. So the cubed root of -8 is -2. The cubed root of -1 is -1. Cubed root of 0 is 0. Cubed root of 1 is 1, and the cubed root of 8 is 2. So if we want to graph these points, start at 0, 0. Put those points on here. And then you connect them better than I did. And your turning point is going to be 0, 0. Since it covers the entire graph here, our domain is all real numbers. And our range is also all real numbers, since it'll go forever in both directions. So transformations are the same for both square root and cube root. H is going to be your horizontal shift. Where plus shifts it to the left and negative shifts it to the right. I think I said that backwards, but that's what I mean. Nope, I did say that. I wrote that backwards, I said it correctly. Sorry. So plus shifts it left and negative shifts it right. I'm sorry that I messed that up. K is going to be our vertical shift. Plus is going to be our up, and negative is going to be down. Endpoint or turning point will be your HK, which in other things has been your vertex. We don't have a vertex in these, so if A is negative, the function is reflected across the x-axis. If the absolute value of A is greater than 1, then we have a vertical stretch. And if it's between 0 and 1, we have a vertical compression. We're going to talk about some transformations. I'm going to do the odds here. So this 7 is going to shift it to the right. So right 7, and then the 2 is going to make it go up 2. 3, the negative here is going to reflect over x-axis, and the 3 is going to go left. 3. So if I want to write some, given the transformations, if I have a square root and it's reflected over the x-axis, that's going to make it negative. F of x is going to be negative square root of something. X, because it's shifted 7 units left, so it's going to be a plus 7, and then 1 unit down. And then what about if I give you one that has a turning point? So that's h and that's k. So f of x equals the cubed root of x plus 2, because it's minus a negative, plus 3. So that's how you do that. I'm going to do 8 here, since I did both of those. So let's talk about our transformations. So this negative 4 is going to take it down 4. Usually I start at 0, 0. But that's going to shift it to 1, negative 4. Zoom in. So that's my turning point, or my end point in this case, because it's a square root, not a cube root. So 1, negative 4 is my end point, not my turning point. My domain is x is greater than or equal to 1, and my range is y is greater than or equal to negative 4. Because from here, I don't stretch it at all, so I just have the same thing that I had before. I go over 1 and up 1, and then over 4 and up 2. And I could go over 9, but I'd run out of room on my graph here. Now we're going to talk about in behavior. So as x goes to infinity, f of x is going to go to infinity. Strange looking. And then I don't have a negative infinity side, so as it goes to 1, or this point right here, because that's where it stops, it's going to negative 4. My increasing intervals is always increasing, so it's increasing from 1 to infinity, and then it's never decreasing, so we don't have to worry about that. And then we're going to move on to number 10. And we'll do 10 and 12, and we'll call it good. All right. So I usually start at 0, 0, but this is h and that's k. So I'm going to have negative, positive 2 and 3, because that's a minus. So my end point, since it's a square root, not a cubed root, is 2, 3. It's going to be flipped over the x-axis because of this negative right there. My domain is going to be x is greater than or equal to my x-coordinate, and my y, it's going to be y, my range is going to be y is less than or equal to 3. Less than or equal to this time because it's flipped over the x-axis. So I'm going to start at the point 2, 3. And I'm still going to do the same thing, except instead of going up, I'm going to go down. So over 1 and down 1, and then over and down 2. So once again, we're going to talk about in behavior. So as x goes to positive infinity, f of x is going to negative infinity. And then as x goes to 2, y is going, or f of x is going to 3. If I read this from left to right, it's never increasing, so we don't have to worry about that. But it's decreasing from 2 to infinity. So those are how you do transformations and the characteristics for square roots. Let's do number 12 so we can look at a cubed root. So I have some extra things here. I have a negative, and I have a 2. Well, the 2's going to stretch. DCH. It helps if I can spell. And then the negative is going to reflect. So, I'm still going to start at my point 0, 0 because I don't move it left or right. And so my turning point is still going to be 0, 0. And my domain and range aren't going to change. They're both going to be all real numbers. From your parent function, they don't change. So, and then we are going to, usually you go over 1 and up 1 because the cubed root of 1 is 1. However, because of the negative and because of the 2, I'm going to go over 1 and down 2. And then in the right direction. And then I'm going to go over from my turning point, left 1 and up 2. And then to get the next point, we know that the cubed root of negative 8 is 2. So we'll go negative 8. And usually I go down 2, so I have to double that and go up 4. Same on the other side. I think I miscounted here. So that's your function. Your end behavior here is as we know it, with infinity and negative infinity. So as we go to infinity, my function is going to negative infinity. And as we go to negative infinity, my function is going to positive infinity. My function is never increasing as I read it left or right. So that means it's always decreasing, which is negative infinity to positive infinity. So that's how you graph transformations of functions.